today we're going to look at some trig identities. As you watch this video, make sure you keep up on the notes, or you can use this to look back at. So for trig identities, we have reciprocal identities. So the reciprocal of sine theta is 1 over cosecant theta. So then we have cosine theta is the same thing as 1 over secant theta, or the reciprocal of secant. Tangent theta is the same thing as 1 over cotangent theta. Cosecant theta is equal to 1 over sine theta. Secant theta, if you've guessed by now, is equal to 1 over cosine theta. And that means cotangent theta is the same thing as 1 over tangent theta. So not only do we have reciprocal identities, we also have quotient identities. So our quotient identities look like this. So tangent of theta is the same thing as sine theta over cosine theta. Cotangent theta, so if cotangent is equal to 1 over tangent theta, then that means cotangent of theta as a quotient identity would be 1 over sine over cosine, which gives us cosine theta over sine theta. Then lastly, we have our Pythagorean identities. So our Pythagorean identities, we're not going to have to touch this first one. We have sine squared theta plus cosine squared theta equals 1. And then sine squared theta plus cosine squared theta equals 1. But this time we're going to start manipulating that a little bit. So Pythagorean, kind of like our a squared plus b squared equals c squared. If you look at your unit circle, that's where these come from, making those triangles. All right, so if we take this sine squared theta plus cosine squared theta equals 1, and we divide all of this by sine squared theta, sine squared divided by sine squared is going to give us 1, plus cosine squared theta divided by sine squared theta. Well, this cosine over sine we see up here. That's going to be cotangent squared theta. And that's equal to 1 over sine squared theta. That 1 over sine from our reciprocal identities. So this will be cosecant squared theta. Then lastly, let's do the same thing again, but this time we're going to divide by cosine squared theta. So this time we have sine squared divided by cosine squared. And using our quotient identities, that's going to give us tangent squared theta plus cosine squared divided by cosine squared. That's going to give us just 1 equals 1 over cosine squared theta, which using our reciprocal identities, we know will be secant squared theta. So all of these reciprocal identities, all these quotient identities, and all of these Pythagorean identities are going to be really helpful to us as we start proving identities. So let's work through some of these. So to prove this identity, we have cotangent theta divided by cosecant theta equals cosine theta. So this is a true statement, but we have to figure out how in the world did they get from that cotangent theta over cosecant theta all the way to just a simple cosine of theta. So let's use some of our identities. So using the quotient identities for cotangent, I can say that cotangent theta is the same thing as cosine theta over sine theta. All right, so that was in place of cotangent. Then we have divided by cosecant theta, which if I use my reciprocal identities, I know that cosecant theta is the same thing as 1 over sine theta. And I know, given the problem, that that's all equal to cosine theta. So when you're starting these, I like to see where I'm trying to end up. So since this is in terms of cosine, I want to get as much as I can into terms of sine and cosine as possible. Or cosine, the reciprocal of cosine is 1 over secant. So terms of secant could be helpful too. You're kind of looking, how can I get as close as possible to the terms I want my solution in? All right, so I have cosine over sine divided by 1 over sine equals cosine. And I don't like to look at division like this. So instead, I'm going to turn this into a multiplication problem. So I have cosine theta over sine theta. And I know that dividing is the same thing as multiplying by the reciprocal. So I'm going to say times, instead of 1 over sine, I'm going to take the reciprocal, and I'm going to say that's sine theta over 1. And it's given that that's equal to cosine theta. So now, multiplying this out, sine theta divided by sine theta is going to be 1. So those are going to cancel. And I'm left with cosine theta over 1 equals cosine theta. And we know that cosine divided by 1 is just cosine. So I get cosine theta equals cosine theta. Both sides match, so this is considered proven. All right, let's skip down to number 3. This time I'm going to keep what is on the left as it is. So this tangent to the 4th theta is equal to, right now, tangent squared theta times secant squared theta minus tangent squared theta. So now we can use what we know about factoring to take out our greatest common factor. So the greatest common factor between these two terms would be tangent squared theta. So let's go ahead and take one of those out. So I can take tangent squared theta out, and I'm left with secant squared theta once that's divided, minus tangent squared divided by tangent squared is just 1. So now, what I have, I'm going to keep my tangent squared to the 4th theta equals, and then I'm going to manipulate the right side of this a little bit. So using those Pythagorean identities, we have an identity that looks like this. It says tan squared theta plus 1 equals secant squared theta. If I rearrange this problem a little bit, what if I make it so it looks like this? What if I subtract 1 from both sides? Then it turns into tangent squared theta equals secant squared theta minus 1. So now you see this matches what we have up here. So I'm going to substitute this tangent squared theta into this right here. So now I have tangent squared theta times tangent squared theta, subbing that in. So now I have tan to the 4th theta still equals tangent squared times tangent squared. Same base, small add. We're going to have tangent to the 4th theta. And this one is proven.